Once again, ladies and gentlemen, I'd like to welcome you to today's MSDN webcast entitled Using SQL Server 2005 Integration Services to Populate a Kimball Method Data Warehouse. I'd like to introduce today's presenter, Joy Mundi. Joy is from the Kimball Group. Joy, you now have the floor.
Thanks very much, Stan. Well, everybody, welcome. Thank you for joining us today. I'm not going to repeat that incredibly long title, which I have to confess I came up with, but you can all read it in front of you. So what we're talking about today is how to develop the extract, transformation, and load system for your data warehouse. We're going to talk about some common themes in an ETL system. What are the common tasks in that system? And we'll talk about how you use integration services to effectively build ETL systems flexibly.
Hey, Joy.
Yes.
I believe are your speakers on?
Hey, Joy. Just a moment. Is this better?
Go ahead and speak one more time for me.
I'm speaking
Much.
again.
Go ahead and speak one more time.
I'm hearing a lot of feedback, but I don't think it's from my computer.
Okay, well, keep going, and I will see if I can troubleshoot it.
Thank you.
Thank you.
Okay. In order to to understand effectively what we're talking about today in this presentation, it's helpful if you understand a little bit about data warehousing principles. I'm not expecting you to be major data warehouse architects to do that as your primary job and to have done so for 20 years, but it does help if you understand the basic principles, if you know what dimension and fact tables are, surrogate keys are, and understand a little bit about what ETL is. You do need to have a basic understanding of the relational database and how it works, and some familiarity with integration services. I'm going into a little bit of detail on things that are moderately complex in integration services, so it helps if you've seen the user interface before. I'll try to go slowly, though, so that everybody can keep up. The presentation is in two pieces. The first, perhaps third to a quarter, is talking generally about issues about integration services and designing the ETL system, the role of integration services in data warehousing. And then the second piece of the presentation, which is probably 2/3 of the time that I'll spend, is spent on a lot of demos about different components of integration services. And what I'm particularly focusing on today is using variables and scripting effectively in your integration services system. What I like to do is to build packages that don't use scripts as much as possible, but that's unrealistic. And a lot of people face a fairly high barrier in moving from the widgets that are presented to you by integration services that are very easy to use to move past them and to do a little bit of scripting. And what I want to do today is show you where you actually need to move past some of the basic components that are built in advance for you, where you need to do some scripting, and also to show you that it really isn't very difficult at all. The next, this slide that we're looking at now is something we've all seen before, a simple data warehouse business intelligence technical architecture. I'm not going to go through this in detail. The main thing that I want to show you is how this technical architecture, where we start with data in source systems, we extract it, transform it, and load it into a relational data warehouse and perhaps an OLAP database. Then we present that information to business users in a variety of methods. How that entire architecture, what part of that we're talking about today. And what we're talking about today is integration services and the ETL component. When we're looking at a Kimball method data warehouse BI system, which is, after all, part of that very long title I put on the presentation, what do I mean by a Kimball method data warehouse BI system? The most important feature of a Kimball method system is that it focuses on the business. And this is easy to forget, especially when we're talking about ETL and some of the back room components of a data warehouse. We seem very far removed from the business users, but it's really important that we always keep in mind that the business users are, after all, what we're building this system for, and to keep in mind their requirements when we're deciding how to go about solving a problem. Another key feature of a Kimball Data Warehouse BI system is that it's dimensional. Now, we can and do go on at great length in some Kimball group courses about what a dimensional Data Warehouse BI system is, and I don't have time to do that now. I just have a couple sentences about it. But at its most basic, a dimensional data warehouse contains fact tables that are at the finest grain of data possible. So that's at the transaction or sub-transaction level. Whatever the finest grain is that it's available to you and can feasibly be loaded into your system, that is the grain of data that we like to see in the dimensional data warehouse. In addition to the granular fact tables, you should build dimension tables that are conformed across the enterprise. And what I mean by conformed across the enterprise is that there's one version of a product table that uses the same key so that you and your business users can join information easily from one set of data to another set of data. Now that act of conforming the dimensions, conforming product and conforming customer, is a huge task that is generally borne by the ETL system, which is what we're talking about today. Within the Microsoft world, in general, we recommend that your ETL system populate a relational dimensional model. So fact tables and dimension tables in the relational database. And then downstream from that, you populate one or more analysis services cubes. And generally, we've found greater success in using analysis services as the primary presentation server rather than the relational database. The relational database is a very important component of the technical architecture, and that's the primary destination of the ETL process. All right, let's talk a little bit more about the ETL process and what we mean by that and what kind of activities go on in the ETL process. Well, the ET and L tell you basically what's going on. First, we extract the data. We pull or sometimes push the data from the source systems. And there, our biggest issue usually is identifying the changed rows. What are the new rows? What are the updated rows? What are the deleted rows that occurred since the last time we extracted data from the system? Next, we transform the data. We clean the data. We integrate multiple systems, as I was just talking about. We manage dimension keys. And we look up surrogate keys for incoming fact rows. Finally, we load the data. By the time we're set to load data into a target table, the data should be clean. It should be ready to load into the target tables without error. We really don't expect to see any errors by the time it comes time to load data into a table. And so the biggest issue that we struggle with on the load process is performance, to make sure that we can load data into a target table as quickly as possible. Speaking in more detail about the E portion, the extract, we often pull, especially in the modern world, in recent years, we're pulling increasingly from relational sources. If the source data are in a relational database, then we usually pull that data from the ETL system. We use a query in integration services to pull the data directly from the source system. It's really important when you're designing your ETL system that you keep the source system query simple, that you keep the query that actually pulls the data out of the source system as simple as possible. My rule of thumb is to use no more than to join no more than 2 or 3 tables together in that source query, and definitely work very closely with the source system DBAs to make sure that the query that you're structuring that may pull a fairly significant amount of data from the source system, to make sure that that query is going to perform well and not unduly impact the source system, the transaction system that's operating the business. In integration services, we implement that source query in the data flow task, the OADB source transform within the data flow task. And in a few minutes, I'll show you a demo of where that is. If our sources are non-relational, then they're usually, though not always, pushed from the source system. It's common to have some kind of job on the source system that generates flat files and maybe FTPs them or copies them over to the ETL server. Third-party connectors can also pull from non-relational sources from within integration services. And in fact, Microsoft ships a fairly simple SAP connector that will let you attach to SAP. Now, of course, SAP is relational, but we all know it's odd enough to sort of fall in the gray area between relational and non-relational. I mentioned already that one of our biggest challenges when we're working with extracting data is to identify changed rows. One of the most effective ways to do this, if you can get permission to implement replication on your source system, on your transaction system, is to write some kind of application logic, such as replication or triggers on the source system that will pull out the changed rows for you. That will automatically feed your extract system the rows that have changed since the last time you ran your ETL extract. Alternatively, there are third-party log readers that you can implement. And then if your data volumes are very small, you might be able to get away with pulling all of the data that's in the source system. But in that case, you need to do a very expensive row-by-row and column-by-column comparison to see which one has changed.
Hey, Joy.
Yes, Cindy again. I'm sorry for the audio difficulties.
Hi, this is Joy Mundy again. I'm sorry for the audio.
Does it sound better? Well, I'll just keep going. After we've extracted the data, our next challenge is transforming it. And one of my main messages, my main words of advice here, is particularly relevant for people who are expert with DTS 2000, Data Transformation Services, and SQL Server 2000. With Integration Services 2005, we want to use integration services to do as much transformation as possible, rather than using the relational engine. And as I point out on the slides, this is a different strategy than for SQL Server 2000 DTS. In DTS, we tended to use the relational engine. Integration Services has a data flow pipeline that is efficient. And the goal in Integration Services is to perform our transformations in memory and minimize data writes as much as possible. So writing data is like the most expensive thing we can do. We want to do it as seldom as possible. I add a caveat usually here because there are times when, for performance reasons, it really does make sense simply to write the data down and into the database, and then we can use the power of the database to perform some complex manipulations. We also want to write data for logging and auditing purposes. Another recommendation on the transformation piece of the ETL is to make sure that we do data quality checks when we extract the data. And I'll walk through an example of this in the demos, but what I want you to do is make sure that when you extract your data, you know how many rows you have, and perhaps compute a checksum on a value, or count. The example that I show is counting the distinct number of products that we're extracting in our fact table extract. Compute that when you extract the data, and then compute it again when you load the data, and make sure that you are actually loading all the data that you extracted, or that you know where all the rows went. Transformation logic, by and large, is very custom to your environment. There isn't a lot of best practices that I can show you about transformation, because it really is unique to your environment, to the systems that you have, and how you're integrating data. But there are some elements in common. Those surround dimension change management, and also in the fact table loads, the surrogate key lookups. And I'll be illustrating that to you again later in this presentation. When we get to loading data, I need to take a little aside here to talk about how we load data fast. This isn't particularly about integration services. It's information that's very important for you to understand, though, when you're designing your ETL system. You need to understand what loading data fast means and how you do it. So first of all, there are several bulk load techniques in SQL Server relational database engines. These include BCP, which has been around forever, bulk insert, and select into, all bulk load techniques, and also the integration services, OLADB, or SQL destination adapters, also use a bulk load technique. But bulk load is a necessary condition, but not sufficient condition for loading data fast. In addition, in order to get data to load fast, the table has to be empty, in which case it can have indexes on it, or the table can have data in it, but it can't have any indexes in it. And fast load is really exciting and important because it's like 10 to 100 times faster than not fast load. So fast load is really fast compared to not fast. Unfortunately, those conditions about the table being empty or having no indexes are hard to fulfill in the case where we're incrementally populating our data warehouse over time. It's something we can certainly do during the big initial load of historical data into the data warehouse, but it's hard to meet those conditions during the daily or weekly or monthly incremental loads after that. One of the techniques that we now have in SQL Server 2005 that makes fast loads more possible on an incremental basis are partitioned tables in the relational database. It is possible with partition tables to be loading data incrementally and to do very fast loads. For the rest of us, we'll be using the Integration Services OLEDB destination adapter. We'll certainly do this for the historical load. And this is definitely preferred over BCP or the other old-fashioned techniques. We want to be loading directly into our target tables from within Integration Services, from within our ETL system. And I do recommend that you not use the SQL Server destination adapter. I make a point of this because the books online for SQL Server actually recommends that you use the SQL Server destination for best performance. The problem with the SQL Server destination is that it doesn't let you commit rows at checkpoints. It requires that the whole transaction be committed together in one big transaction, and this is going to create a very significant memory burden on your server, on the server where the relational database is running, not the Integration Services server, the server where the relational database is running, because all of the rows in that particular load need to go in one transaction. The OLEDB destination adapter does let you set a commit point every 1,000 rows or 10,000 rows, and so that is generally preferred to the SQL Server destination adapter. Another strong recommendation that I have for you when you're loading data within Integration Services is to make sure you set up an error flow on the load. Error flow is one of the best features, one of the most important features of Integration Services, one of the reasons that we really like to use Integration Services over more old-fashioned handcrafted scripting. Integration Services let us take rows that would fail on an operation. In this case that we're talking about, it's on an insert operation. We can just send those rows that would fail off into another flow and do something with them. We may be able to fix them up, but at the very least we can write them to a file and fix them up at a future date. We're coming to the end of our general discussion about Integration Services and ETL, and we're moving towards the demo phase of this presentation. And before we do that, I just want to quickly walk you through the data model for the examples that I'm going to be showing you. This is a very simplified version of the AdventureWorks data warehouse database that ships with SQL Server. My source database is the AdventureWorks transaction database, and then this is a really, really simple dimensional schema, a new database that I've created that is a 4-dimension star schema with one fact table called orders and 4 dimensions, product, date, promotion, and currency. And I've collapsed the dimension tables down just to show you the keys. There are, of course, many other attributes in those tables. Now, remember, a fact table is going to have foreign key references to each of the dimensions. So product key goes to dim product, and order date key goes to dim date, and so on. Now, you might wonder about this large table in the center called dim audit. This is my audit dimension. It's a simplified method of tracking information about every row that is loaded into the data warehouse database. And I think it's very important that everybody build an audit system into their data warehouse. So as you can see, every dimension table has a key for which that links to the audit dimension for when that row was inserted into the table and when that row was updated in the table, and the same, of course, for the fact table as well. So what the audit table does is it receives a row whenever a package is executed, whenever a package is executed that either inserts or updates data in the data warehouse. So we can always find out where and when and at what time information was loaded into our data warehouse. This will make your internal audit department, if you have one, very happy to see that you've implemented a structure like this. Okay, so with that quick overview of the data model that we'll be using in the examples, it's time to move on to more detailed examples about integration services and how we build the ETL system in integration services. We'll talk first about master and child packages. Then we'll talk a lot about how you can use variables and how you actually will use variables, the minimum amount of work that you need to do to build an enterprise-class data warehouse ETL system, and where you're going to be using variables in that system. We'll talk about how you conditionally halt package execution, and then we'll work through a very complex example of the fact table surrogate pipeline. Okay, so my first recommendation for designing your ETL system in integration services is that you modularize your system. Now, in theory, you could write one package that does everything, that populates all of the tables in your data warehouse. You could write just one package to do that, but please don't do that. That is going to be very hard to maintain over time. What you want to do is create a master package that's the traffic director, and that master package contains lots of execute package tasks. So there is a task called an execute package task. The master package simply calls a bunch of other packages by way of the execute package task. Then create a child package for the normal processing of each target table. So a package for the product dimension table, a package for the date dimension table, a package for the fact table, and so on. Create separate projects for historical loads, for unusual events such as backing out a load. Make sure, by the way, that you both develop and test that package for backing out a load during the development cycle for your data warehouse. When the time comes, which is almost inevitable, when the moment arrives when you do need to back out a load, that moment is not the time to be developing and testing this package. You need to do it in advance so that you're confident that it works. When you can pass variables down from the master package to the child package, and those of you who are familiar with DTS 2000 will find that this works much better in Integration Services 2005 than it did in 2000. It's really very simple to do. What you do is define variables in both packages. In the child package, you set up a configuration and make sure you set the configuration type to be a parent package variable. And that's all you need to do to communicate from the master package to the child package. So then the next question is, how do we communicate after the child package has finished running? How do we communicate information back from the child package up to the master package? Well, that's a lot harder. There's no direct way to do that. And in fact, really the only way to do it would be to have the child package write a piece of information somewhere, perhaps to a table or a file or a system variable. And then the master package, when control returns to the master package would need to access that information. And I'll show you how to do that. So it's not that hard, it's just very awkward. I'm going to demonstrate how you set up what a master package looks like, what a child package looks like, and then how you set up this communication between the master and child package. All right, what we're looking at here, of course, is the integration services design surface in Visual Studio, BI Studio specifically, so the Business Intelligence Development Studio. And I'm looking at a master package here, which I have cleverly named master package. And you can see at the top, I have a couple of setup tasks. So a master package, they always look the same. So you start off with some setup steps. In this case, it's I'm cleaning out the fact table. I'm getting some audit information. Next, these guys are execute package tasks, and all you do with them, you might think if you double-click here on dim currency, I'm double-clicking, you might think that it would actually launch the dim currency package, but no. All it does is bring up a simple editor that points to where that package is. If I want to edit that package, I need to do it over here in the Solution Explorer. Just for ticks, I'm executing two sets of dimensions simultaneously. So the currency and promotion are serialized, but these two are executing at the same time that date and product are executing. Only when all four dimensions have finished do I go on and execute my, process my fact table. So launch the package that populates the fact table. And then, of course, almost all master packages will end with some cleanup steps as well. So a master package is very simple. Let me show you some of the variables that I have in my master package. Some variables I'll communicate down to my child packages. Sorry for making that go in and out. The ones I want to show you are my extract start date and extract stop date. So of course I want my entire system to extract the same date range when I run it. And I set those in variables. So here I have extract start date from 1/1/95 to December 31st, 2005. Then in a child package, I can go over to any of my child packages. They're all set up the same. In a child package, I also have those same variables, extract start date and extract stop date. And then the trick in the child package, I'm right-clicking on the background of the designer and choosing package configurations. And you can see that I have a configuration called extract start date and a configuration for extract stop date. And then the trick is that I've set the configuration type to be parent package variable. The default is to set a configuration from an XML configuration file, but to do the master-child communication, you want to set it equal to the parent package variable. And again, remember this communication that I'm talking about here is from the master package to the child package. Again, if you want to get some information after the child package has finished running, back up to the master package, then what you'll need to do would be to write a variable, probably to a table in the relational database, and then up in the master package you would need to read that parameter from that same table. Now, we use variables a lot. You will be using variables a lot in your ETL system in integration services. You can use variables and expressions almost anywhere in the control flow. The control flow is the surface that is the part of your package that it is aptly named that controls the flow of logic in the system. So the control flow is where you can make decisions about whether to proceed or halt execution of a package. There's a second design surface called a data flow, which again is aptly named, and the data flow is about the flow of data within a pipeline. So variables and expressions are very common. You'll use them in many places throughout the control flow, and you have a lot of places that you can use them in the control flow. One place you absolutely will, I'm certain you'll use variables, is in the execute SQL task. You will be parameterizing a SQL query or stored procedure, and you'll put the results of a query into a variable. And we've already talked about how you need to do that if you're communicating from a child package to a master package. So let's just take a look at what that's going to look like working with variables in the execute SQL task. On our master package, I have a couple of execute SQL tasks. The first one that we'll look at is the get audit key execute SQL task. So I'm double-clicking on it to open it. I'm double-clicking on it to open it. And what I wanted to show you is what I'm doing here is I'm inserting a row into that audit dimension. So remember that audit dimension, I want to put a row in that audit dimension every time a package begins executing. So I have a simple SQL statement that's going to put a row into the audit dimension, and that is a parameterized SQL statement. And I'm also going to get back from the relational database the key of the row that I just inserted. Rather than making you look at this small tooltip, I have the SQL here over on the right-hand side, which I will show you. Okay, so this is the SQL that is within that execute SQL task that I was just showing you. So all it is an insert statement into this table. It's just insert column names and values, and the trick is that these are parameterized. These are parameters. Some of them are system parameters, and some of them are user variables that I've created. And then after we've inserted the row, we get the key that we just inserted. So now let me go back to the execute SQL transform and show you how I set that up. The first thing I want to show you is the parameter mapping. So I have like 8 parameters in this SQL statement, and these are my integration services variables. As I said, many of them are system variables, and some of them are user variables. And then these are the parameters that are in that SQL statement. So in this interface, I simply map my integration service variables to the parameters that are in my SQL statement. That's very straightforward. The next thing that I want to show you is, remember, after I've inserted that row into the audit table, I want to get its key back. And the way I do that, there are 2 things I need to do that. The first is I change the result set to be single row. So by default, I'm not expecting a result set back from my execute SQL task, but I changed it and said I'm going to get a single row back. And then, of course, the next thing I do is just map the parameters to the variables. So here, I'm only bringing back 1 column. That column is the audit key, and I'm mapping it to my integration services variable, also called audit key. Now, you might notice that here I have named parameters, and I've been pretty consistent about naming my parameters the same as my variables. The reason you can do this, so an astute observer might wonder how I was able to do that, because the OLEDB syntax doesn't support named parameters on input. And the answer is right here in the ADO.NET connection type. I use an ADO.NET for the execute SQL task because I like to name the parameters. I generally have a lot of input parameters, and I like to name them. Otherwise, I have a lot of trouble just figuring out a couple weeks later what in the world I was doing with that query and what the first, second, third, and fourth parameters are. So if you use the ADO.NET connection, then you can name your input parameters. Okay, so when this task finishes executing, I have a variable populated, a user variable populated that has my audit key in it. The next thing that I want to show you is in the data flow. So as I said, you can use variables and expressions a lot in the control flow, and it's extremely valuable here. It's less useful in the data flow. There are fewer places where we can write data in where we can write variables in the data flow. And let me show you what that looks like. So first of all, I'm going over to the promotion package because the master package doesn't have a data flow in it. What we're doing here is I'm moving over to the data flow view of one of the data flow tasks in my promotion package. And the first thing that I want to show you, one easy place or valuable place to use variables in the data flow is in the source query. And so I double-clicked on this transform. This is my source query that's just a very simple select statement from a single table in the source system, and I've parameterized it with that OLEDB syntax of question marks. So I have again, this is my same extract start date and extract stop date that we've already been looking at, and I map them to my parameters here in this parameters user interface. Another place that I can use that I can write variables in the data flow is in a row count extract. This is a very common place to do it. So right here, this transform counts the rows that are flowing from left to right, and it's set up simply by writing to a variable. So this variable called row count extract receives at the end of execution, it receives the count of rows that flow through this transform. Let me switch over to my fact table package and show you a third way of writing a variable from within the data flow. I'm going to switch over to the data. I'm looking at it. I know there's a lot going on in this package, but I'm just going to switch quickly over to the data flow for the fact table. And what I want to show you is, remember early on I said that when you extract data from the source system, you should immediately compute, you should count the rows that you have extracted, and you should also compute some measure of reasonableness. In this case, what I'm doing is I'm actually going to compute two things. One is a row count by date. So I'm going to have a multi-row result set that has every day of data that I'm extracting from the source, and also the count of rows by that day. And then the other thing that I'm calculating is just a count of distinct products that are in that extract. So these are sales orders for perhaps several months of transactions, and I want to know how many products, how many distinct products were included in that extract. I did that from the aggregate transformation editor. And the main thing that I'm showing you here, there are two things that I'm showing you. One is that I can do multiple aggregations within the aggregate transform. And this is order date is effectively just a group by count star. And then the count distinct products will return one row, which is just the count of distinct products. Because I computed two aggregations within this aggregate transform, I have two flows coming out of that transform. And each of them is going into an ADO record set. These are very simple to set up. Again, just like the row count transform, all you need to do is supply the variable name, in this case, row set product distinct count. Because this is a single row set, the count of distinct product is just one number. Alternatively to writing it to an ADO record set is I could have written this number down into a table. It's common to have a parameters table in your staging area or your data warehouse. So I could have simply written this to a table, and then I could have accessed it from the control flow. Unfortunately, the record set is the only sort of elegant way to get a variable value from the data flow out to the control flow. You can't set a variable, a static single variable in the data flow and get it out to the control flow except by using the record set transform or the row count. Okay. All right, so I just demonstrated most of that. So I talked about how it's possible to use the control flow in to use variables in the control flow very flexibly. Inside the data flow, much more limited use of variables. And I showed you how to parameterize the source query. I showed you how to write the row count to a variable. And again, I want to remind you that other than the few things that I showed you of the ways to set variables inside the data flow, there are very few ways to actually set a variable in the data flow. There is one more thing that I want to show you where we access data in the data flow. A common place to access data in the data flow is to add a variable to the data flow. So let's say I have data coming out of my extract, which is what I have here. I've extracted data from a staging table. So here we're looking at it, it's just a select star. And I want to add a column to that data flow. That's very easy to do. This is a derived column transform, and I'm adding 4 columns to it. The first 2 are based on variables. So the insert audit key just is set to a variable that I set out at the control flow earlier in my package. Now, a couple demos ago, a couple of minutes ago, I showed you how I parameterized the source query by setting the extract start date and the extract stop date as parameters in the query. And remember, we used the OLADB question marks there. So there are often scenarios where that's not sufficient, and unfortunately OLADB does not give us a great deal of flexibility about where we can parameterize a query. It's not really dynamic SQL. So a question that you may have is, well, what if I need more flexibility than that? What if I need to parameterize something that's not in the where clause, or it's not the bound values in the where clause, but something else that effectively requires dynamic SQL, and I want to make that be part of my source query. So, for example, perhaps you want to change the name of the source table at runtime. Maybe you're pulling from a staging table that contains every day's load, so it's a daily pull, and when that staging table is created, it names it by post-pending the date, 2007-07-11. And again, the OLADB source query can't handle that. That's not the kind of flexibility that the OLADB provider can handle. So the solution is actually pretty straightforward. It requires a couple of steps, but it's really not hard. What you do is you create a string variable that holds the query text. So it's going to be a string variable that will hold a lot of text. It'll be a long string. And again, this is an integration services variable. And then in the control flow, you'll write a script task that constructs the query text and puts it into a variable. So effectively, you'll use VB to write a very simple VB to write a script that generates query text. And then in the data flow, you source from that variable. And just as a hint for making this work for you, make sure that when you're setting up your data flow first, you use a static query string and then play with parameterizing it and making it dynamic. And then it's really important that you understand that there are limits to what you can change when you're building the dynamic SQL. So what you cannot do is change the shape of the data flow. And by shape, I mean the number of columns, the names of columns, and the data types of columns. So if you can construct a SQL statement that generates the data flowing out of it that looks the same as the last time the package was executed, then it's going to work just fine. But if you want to add a column or change the data type of a column, then it's not going to execute correctly. In fact, it's not going to execute at all. So just be very careful about that. Okay, so the next thing I want to show you is what an enterprise class package flow is going to look like. I've already talked to you a little bit about the things that we do in building integration services packages to make sure that the system is going to be flexible and resilient to errors and to changes. So an enterprise class package flow always is going to look basically the same. There'll be some control flow tasks at the beginning that set some things up. In my simple examples, all my setup control flow tasks do are truncate tables and set up my audit dimension information. Then you'll have a data flow task that extracts and writes untransformed data and computes your data quality checks. So we already took a quick look at that one. We're pulling data out of the source system, and before we've transformed it, we want to write a copy down to a file or to a table. And as we're doing that, we want to compute data quality checks. The reason that we write the untransformed data down, there are two reasons actually. The main reason is for auditability. Your internal audit department is going to be happy to see that you have written the untransformed data down and that they can do some kind of analysis to make sure that what you've put into the data warehouse actually matches what came out of the source system. So auditability is the first and primary reason, and the second and sometimes equally important reason is restartability. If something happens and you decide you need to restructure your ETL system, perhaps a couple weeks in the future, it can be extremely difficult to recreate history by going back to the source system. But if you have the source system extracts just filed and archived away somewhere, then you can restart the process from those extracted files, and it works very smoothly. So that's your first data flow task. Then again, in the control flow, what you're going to do is test those data quality variables. So make sure you have a reasonable number of rows, that you're not, if you're expecting 50 million rows, make sure you didn't extract only 10,000. That's probably an indication that something went wrong. Any other data quality tests that you've done, perhaps checksum on one of the variables, you want to look at that and make sure it makes sense. And then you'll have conditional flow, conditional execution of the rest of your package. So if the data quality passes your tests, then you will continue to a second data flow. If not, then you'll halt and notify the operator. Finally, the fourth section of your package will be some final control flow tasks that close out auditing and clean up the communication to the parent package. Okay, so I'm quickly going to illustrate the overall package structure. And we've seen a little bit of this already. What I want to be looking at is the control flow for the fact table extract. So as I said before, remember there are four sections. There's a setup section. In this case, I've hidden it away because it's not very interesting. But I pre-delete some rows. I check a row count. I get my audit key. Okay? So that's the first of those four pieces. The second is a data flow step, and so what we're looking at here is a data flow step. And this data flow step does two things. It extracts the data from the source system, and it computes my data reasonableness checks. And again, let's take a quick look at this. I have a very simple source system query. I use the multicast operator. And what the multicast operator does is it takes a complete copy of the flow that goes through it. So everything that comes out of here shows up in both this arrow, this part of the flow, and in this part of the flow. And the flow off to the right, I'm simply doing counting rows, and then I'm putting the data in a staging table for me to use in the second data flow step that actually does the transformation and loading. Then I already walked you through quickly the computing of reasonableness checks, and I put that information into record set variables. And then when we finish with this, control passes back to the control flow. So we exit the data flow, and we go back to the control flow. The next thing I want to do is decide whether I should continue processing or whether we should just pull the plug here. And the way I do that is with a very, very, very simple script. And let me just show you what the script looks like. So this is a script task. And you can write script tasks are written in Visual Basic. In Visual Basic.net. And this probably doesn't show for you. I'm going to quickly copy what I'm looking at and make it available to you. Okay. Sorry, this does show up integrated with Visual Studio. So this shows up as part of Visual Studio, but for some reason it didn't seem to be showing up as part of our webcast. But this script, the first thing I want to say is that it's really simple, and most of it is generated for you. So this part that I'm highlighting right here, actually right here, these are the only lines that I wrote of this script. And I'm not a developer, so I feel like if I could write these 8 lines, but probably everyone who's listening to me can do so as well. All I'm doing here is I'm saying, first I'm getting the values of the variables into this script, and so that's what the first 4 lines are doing, is we're just saying product decount goes into a normal VB variable. And then this if statement is the only thing that has any degree of complexity to it, and its degree of complexity is near 0. So what I'm saying is if the product distinct count is greater than a limit that I set out in a configuration file, and as well the row count is greater than some limit, then everything's good. Then extract OK is true. Otherwise, things are not good. Otherwise, it's set equal to false. And so when I exit this, I have my Boolean value, b extract OK, is set either to true or false as appropriate. And if it's false, then I have a conditional flow coming out of this transform. So if it's false, it's not b extract OK, then we flow to the right, we send mail, and we fail the package. If it is OK, then we come down and we actually execute the real data flow step, the data flow step that picks up the information that we had extracted and saved in a staging table. It transforms it and loads it into the target table. And then finally, the fourth step of our standard enterprise class ETL package, integration services package, is some cleanup steps to clean up our tables and close out our auditing information. The last thing that I want to talk to you about is the surrogate key pipeline. The surrogate key pipeline is a consistent component of your ETL system. So as I said, a lot of the transformation, really most of the transformations that you do, it's hard for me to give you good hints on how what your best practices are because it is unique to your environment. But one thing that is consistent across all applications, at least all applications that populated dimensional, a Kimball method data warehouse, is the fact table surrogate key pipeline. For the pipeline to work, you process dimensions first. We need to make sure that our dimension tables have the most up-to-date information in them and that we've processed any new customers that arrived today or yesterday, any new products or changes to products that occurred yesterday, and so on. After we've processed the dimensions, we clean, align, and check the fact data. And then the last step before we insert the data into the data warehouse fact table is to replace the business keys that are in the source systems, that are in the transaction systems, with the surrogate keys that we manage in the data warehouse. So remember, surrogate keys are generally integer keys, meaningless integer keys that we manage from within the data warehouse. And it's a tenet of the Kimball method data warehouse that you use surrogate keys in all of your dimensions. And so we have a big step when we have for example, the product SKU or the customer account number that's in the flow of data coming from the facts from the transaction system. We need to look up each of those and replace it with the data warehouse surrogate key that we're managing in the data warehouse. We do this in a data flow task, and we make extensive use of the lookup transform to do this. And excellent practice, the best practice for setting these up is to make sure you always handle any errors that happen on lookup. So what an error is, a lookup error, is if you have, let's talk about the product dimension. Let's say you have a product SKU that's coming out of your fact table that doesn't have a corresponding entry in your product dimension table. Now, in a perfect world, of course, this would never happen, but let me assure you that it does in fact happen, and you need to make sure that you're not going to be that you don't throw the rows away, unless that's really what you want to do, and that you're not going to try to insert those rows into the fact table. So you always need to handle lookup errors. There are lots of different ways to do it, and I'll illustrate several of them to you. One of the best approaches is often to insert a dummy row in the dimension table. Okay, one more demo. And this demo is going to be of this the second data flow task in the fact orders package. I'm double-clicking on it. And let me just quickly walk you through it. We're sourcing from the extract. So again, remember, in an earlier data flow task, I extracted the data. And so this extract is just a select star. That's very straightforward. My next step is to do any transformations that are required. Now, in the real world, you'd have more than one simple transform here. You'd have probably a lot of things going on. But because this is demo data, I really don't have very much that I need to do to clean up my fact data. So I'm just creating a couple of columns, doing a couple of calculations. And this is within the derived column transformation editor. I'm adding my audit keys, and then at this point, my data is all clean and aligned. It actually looks exactly like my fact table, my target fact table, with one exception. I have the business keys in the flow coming out of this last derived column transform. I have business keys, and in my target table, I have surrogate keys. So I want to look up for the business keys, look up on the business keys, and find the appropriate surrogate key for every dimension. The first thing we could do, the first way we could handle lookup failures, well, all right, before I talk about the failures, let me just show you what the lookup looks like. This is the lookup transform, and all I'm doing is selecting the product key, and this is the business key, BK product ID, from my product table. And a best practice is always to use a SQL query. Write a SQL query that returns the minimum number of rows necessary in order to make the lookup work. If you use the default of use a table or view, it's going to cache all of the columns that are in that dimension table, and most of them are useless. So you want to write a query that only returns the columns that you want. And then the second thing that you do in setting up the lookup transform is to join on the business key. So we're joining product ID. This is from my fact table flow. Join product ID to product ID and return product key. So when I come out of this transform, my flow, the shape of my flow is exactly the way it was before, except I now have product key associated with it. Now remember I said that you always want to be handling errors, any lookup errors that might occur. And so the default, I'm illustrating the default method of handling lookup failures is to fail the package. So if you just set up the transform the way I did, and you have a fact row coming in that doesn't have that is looking for a product key in the product table, but it doesn't have it there, it's going to fail the entire package, which seems a bit draconian. Let's go on and look at something that's perhaps a little nicer way to handle a lookup error. Next, we're looking up order date. And what I'm doing here is I'm flowing the errors to a file. And you can see that that's happening because this red arrow off to the right. The way I made that red arrow show up was in my lookup transform, I went to configure error output and changed it from the default, which is fail component. Instead, I said redirect the row. So if there's a lookup failure, then redirect the row. And I'm counting those failures, and I'm writing them to a file. What we could do here is, because the error rows are written to a file, some person would probably have to come in and look at that file and figure out what went wrong and add it back into the flow. So this would be a non-automated way to solve the problem, but at least we would be collecting the information and saving it somewhere so that it could be re-added to the data warehouse. A second common method to handle the errors that occur in the surrogate key pipeline is to map the bad rows to an unknown member. In my dimension tables, when I create my dimension tables, I always put an unknown member row in there, and I always make it have a surrogate key of -1. And it's a useful row to have in your dimension table, but I actually try very hard not to use it at all. What we can do is we can say, is, for example, we have our business flow that comes in has both an order date, the date an order was occurred, and then also a due date, the date we think it's going to be shipped. So if the due date is sometime in the future that's not in our date table, we could write those rows to a file as we did up above, or we could say in this case that we're just going to map them to an unknown number to -1, and says it's just some date in the future, we don't know what it is. The way we do that, again, is we redirect the error output. In this case, instead of writing it to a file, we're using the derived column transform and adding the due date key as a new column and set it equal to -1. Nothing could be simpler. Then the two flows go into a union flow. We union the normal error data flow and the error data flow. And then next we go and handle the promotions. And I'm not showing you anything different there. The final one that I want to show you is what I think is the nicest way to handle a lookup error on the surrogate key pipeline. And this solution is to insert a dummy row in the dimension. So let's say we have fact rows coming in. They all have a business currency key, so a business key for the currency of the transaction, but we're missing some of those dimension members in the currency dimension table. What I want to do is to insert a dummy row for that dimension member in the dimension table. And I'll insert as much as I possibly can, which is generally not very much because all I probably have in the fact table flow is the business key for the currency. But I can at least put a row in there. I can get a surrogate key in my dimension table, and maybe I have some default attribute columns that I can set up for it as well. So this first lookup is exactly the same kind of lookup that we've seen before. I'm doing a lookup to the currency dimension table and joining, of course, on the business key and returning the surrogate key. Any errors, any lookup errors, any rows in my fact table that are not in my dimension table flow to my error handling system. In my error handling system, I'm doing a second lookup, and the difference between the first and the second lookup is that the second lookup is uncached. So over in the Advanced tab, I checked this box, Enable Memory Restriction, and that makes this an uncached lookup. The reason I do this is for performance. A cached lookup performs significantly, an order of magnitude better than an uncached lookup. Since I think that most of my data is going to be clean and it's going to get a good hit on currency, then I want to do a cached lookup, and I only do the uncached lookup on error rows. So I do my uncached lookup. Some of those actually, because this currency may have been entered earlier in processing, some of those actually will hit that currency and they'll go through normal processing. They won't actually be error rows. Only if they error out of this will I need to insert a dummy row into the dimension table. And I do that in this SQL OLEDB SQL command transform, and I do it by executing a stored procedure. I have a stored procedure that I wrote that inserts my dummy row into the dimension table. Once it comes out of here, it is absolutely certainly in the dimension table. I do another uncached lookup on it, and then I join these three flows together. And finally, everything is done, and I can write my data into my OLEDB destination. And again, I want to quickly show you the rows per batch and the maximum insert commit size. Make sure you set these. By default, they're set to 0, which means that the entire transaction is going in a single commit, and you don't want that. You want to set this to 10,000, 1,000, 10,000, 100,000. You can play around with it. The actual number doesn't matter, but the important thing is that it not be 0 and it not be 1. 1 would be row by row. 0 means the entire thing goes in a single commit. So you want to do it in discrete batches. And again, as before, we are putting an error flow on our destination adapter. We're counting how many errors we have, and we're writing any errors to a file. Okay, despite our technical glitches, we made it through more or less on time. One of my most important messages is that you make sure that you design the ETL system to meet the business needs. Now, I know that some of the stuff that I walked you through very quickly looks really complicated, and I've seen many ETL teams decide to skip the complexity that comes from developing history of the changes to attributes, for example. Just because designing the ETL system to handle that is a lot of work. But that's really not the point of the data warehouse system. The data warehouse is designed to meet business needs, and the ETL system can only take so many shortcuts before it removes the value of the entire data warehouse system. My next recommendation is that you learn to use integration services effectively and definitely leverage the data flow and error flows within the data flow, which are just really great features of integration services. And of course, modularize your system and create a consistent package flow. You'll find, if you look back on what I've done and what I've illustrated to you today, you'll see that of the, I don't know, like 25 or 30, 35 transforms that are available to you in the control flow. I used about 8 of them. And of the 40 or so transforms that are available to you in the data flow, I used maybe a dozen of them. So there's a lot of functionality that's available to you in integration services. But like any other complex product, you'll probably find yourself just using a pretty small percentage of that. The transforms and packages and tasks that I set up in my sample packages, which will be available to you on the web, show you which are the most important ones to focus on first that you'll be using over and over again. Okay, that for more information, you can get the book that Warren Thornthwaite and I wrote called the Microsoft Data Warehouse Toolkit. Kimball has 2 L's, by the way. He would kill me if he saw that. So you can order that, and you can also download the packages that I showed during the demonstration from the website that accompanies the Data Warehouse Toolkit, and that's right here. You can go to the Kimball Group website to get more information. You can attend one of our upcoming classes on the Microsoft Data Warehouse in depth. And of course, Microsoft has and MSDN have a ton of information available as well. At this point, I'll be joining Warren on answering questions both verbally and we'll finish up with answering some questions in written form. And I'm going to turn the floor back over to Stan.
All right, thank you, Joy. Before we begin our question and answer section, I'd just like to point out a few features. If you'd like to look for upcoming or previously live webcasts, you can go to the site next to the arrow that I posted just there. Also, if you have any ideas for content for maybe webcasts, go ahead and go to the site with the arrow I just posted. And once again, you can use the print to PDF function within your custom panel to actually use these links. These links will not work coming straight out of live meeting. We will be providing a survey for today's event in just a minute. Please take a few moments to complete the survey. The feedback and the comments that you provide us eventually help us create better and more efficient webcasts for you, and your feedback is greatly appreciated. Also, by attending this webcast and submitting an evaluation, you're automatically entered to win this media player right here. I'm going to go ahead and get the survey going right now. Once again, you can ask questions by typing in to the field next to the Ask button, and then of course clicking Ask. Also, just one last reminder that the streaming media replay for this webcast should be available within about 24 hours, and the downloadable PowerPoint and Windows media file will be available for this webcast within about 72. So with that, I will pass it back over to Joy and Warren, and you guys are up.
Thanks very much. Okay, could I review? Sam wants to know if I could review package configuration again. I believe I can. Let me answer some quicker questions. Well, no, I could do that right now. So I'm going to do application.
Joy?
Yeah.
Don't go back.
Don't?
No, because if you change it, you'll lose the...
You're right. Thank you. No, I could not review the package configuration again. Sorry, too late.
But send us a note, Sam.
Yeah, we'll happily walk you through it. Somebody asked if we've had an occasion to connect to Oracle data sources in the 64-bit architecture. Yeah. Yes. So the question is, on the 64-bit architecture, connecting to Oracle data sources, or really any, I will extend the question to be any data source. So yes, there are questions. The issue is that when you're developing your packages, you may well be developing in WoW under 32-bit, but when you are executing the packages in production, if your production server is 64-bit, then are there compatibility issues? And the answer is definitely yes. There are compatibility issues, and it's really confusing because you're in dev mode and everything else looks exactly the same. It feels like you're on like you're doing exactly the same thing, but because you're in 32-bit on the dev machine, especially with x86, then you may well run into compatibility issues. And my only suggestion here is that you have to test. So make sure you have a test machine and that is 64 bits, and that you test executing the packages not through the dev environment, not through BI Studio, but instead through SQL agent or whatever else you're using to actually execute the packages in production. There are incompatibilities, and the only answer is to test. Not a good answer, but that's what it is. Do all versions of SQL Server include the use of variables and integration services? Yes, they do. Everything that I showed you today actually is available in all of the versions of integration services. In all the versions of SQL Server from Developer Edition, Standard, and Enterprise Edition.
Yeah, so that's a good caveat. Let's say those 3 versions. In other words, if you're using Express.
Oh yeah, I'm sorry, I don't know Express. I don't think it
has integration services.
I don't think it does at all.
So, but certainly across those 3, once you have integration services, it has to.
Tim has a question that is a good one, which I didn't illustrate, but is actually illustrated in my package. So the question is, how do you handle banded lookups, so range dimensions? Doesn't the lookup task require an exact match, not a match where a value falls between 2 values, like the upper and lower ends of the range? Is there a way to do this? Yes, Tim, there is, and the package, the solution that I was illustrating actually does that. What I do is I loop over all the days of data in the fact table extract and execute the data flow on a day-by-day basis. So the sad answer is there's no way to force or contort the lookup transform to do what it is you want to do, but there are workarounds. That's one, and the second one would be to stage the data to a table and use a SQL query to actually do that kind of banded join that you're talking about. But definitely download the packages from the book's website, msftdwtoolkit.com, and take a look at what I did there. Very common requirements. Sam says that we load approximately 12 million fact rows a day with 40 dimensions. Would the lookup task scale well enough to accommodate this volume? And Sam thinks that the set-based staged method would perform better at a higher volume. I understand what you're asking there, Sam. The point is that when the lookup pipeline that I showed you had all those lookup tasks attached one after the other, so it looks like they execute serially. And we would say, of course we don't want to do that serially. We want to do several lookups at the same time, maybe even all of them at the same time. So if we stage the data to a staging table, then we can write a query, a SQL query that joins to maybe 4 or 5 or even all 40, conceivably, of your dimensions at the same time and do all those lookups at once. The thing that I think is really cool about the surrogate key pipeline as we implement it in integration services is that it's smart enough to actually execute those lookup transforms in parallel. So even though you simply design them in series, they're just one after another with an arrow connecting them, when you execute it, you'll see that they execute in parallel, which I think is really very clever. So to answer your question, I am inclined to say that the lookup transform, doing the surrogate key pipelines inside the data flow transform using those lookups is the best approach. It scales as well or better Probably not better, but perhaps about as well as the relational approach, especially given the time that it would take to write the data into the staging table. And you have much, much greater flexibility over handling those error flows because you can do anything out of an error flow and do really sophisticated and very nice error handling. How do you avoid rebuilding conform dimensions using the integration services control flow and master-child design? Brian asks how we avoid rebuilding the conform dimensions using integration services control flow and master-child design. And that what I illustrated to you today was on the dimension table loads was just the initial historical load of those dimension tables. We will develop a set of packages that show the best practice techniques for incremental processing of conform dimensions. But those are not what I was illustrating to you today. But it's a design thing. It's not a specific feature that I can point you to that shows you how to do it. Here's another, I think this is going to be the final question that I'm going to answer verbally. I think it's a question of general interest to a lot of people. Sam D asks what we recommend for people who are upgrading to from DTS 2000 to Integration Services 2005, especially when the DTS packages have heavy ActiveX scripting tasks and dynamic properties tasks. So, IC is my first answer to that. As you probably know, there is a package migration wizard that's available to you that takes a good stab at transferring the package from DTS 2000 to Integration Services 2005. But my recommendation is to not use that because the best practice for building packages in Integration Services 2005 is really different. The packages look very different than they look in DTS 2000, and the wizard can't do any of that best practice stuff for you. The best thing it's going to do is just try to make it run the same way it ran before in Integration Services 2005. So what I recommend to people is that you use SQL Server 2005 ships the DTS 2000 runtime executable. So you can actually run DTS 2000 packages on a SQL Server 2005 server. I suggest that if you have a system in production or nearly in production on DTS 2000, that you simply keep it running in the Integration Services 2005 world. And when it comes time to modify that system, if there's a dimension table that gets a new column or you need to change the way something is done, then take that opportunity to do it again and do it correctly in the new Integration Services world. But if it's not broken, don't try to migrate it just for the sake of migrating it. You're really better off just leaving it in DTS 2000. Otherwise, I think it's make work, and it's not going to lead to a result that you're going to find very effective. I think that's it for answering questions verbally. Warren and I will stay on for another few minutes to try to finish up the questions that are still in the queue, and we'll do it not verbally, but I guess that would be non-verbally. We'll do it by typing. Thank you all very much for attending. I apologize again for the sound problems. I hope that it did get better. It certainly was very distracting to me to hear an echo, which is why I was sounding pretty spacey at the beginning. Anyway, thank you all for attending, and good luck.
All right, I'd like to extend a special thank you to Joy, and also Joy for presenting, and Warren, a special shout out to you for answering questions. Thank you everyone for attending today's event. Ladies and gentlemen, that concludes today's Microsoft webcast. You may now disconnect from the audio portion of the conference.